Hello, this is Mr. Rohr, and today we're watching our first video on physics, and specifically we're starting a chapter called Quantities, which will take about 2 or 3 weeks probably to get through, to get a little bit of some of the foundational things required for this class. You're probably wondering, what is physics? What are we signing up for? Physics, I think, is a kind of a combination of math and science, but let's get a little bit more specific with a definition. There are many definitions of physics. One that I like to use is that physics is the study of observable quantities and their relationships. Now, what is a quantity? A quantity is anything that you can describe with a number. There's lots of different things, some examples listed down here below. You've got things like length or width, which you could measure in meters or inches or feet. You have things like volume, which you could measure in gallons, so many gallons, so many cubic meters, so many inches, so many teaspoons. You got things like mass. An average human, for instance, has a mass of 60 kilograms or about 150 pounds. And there's lots of other quantities we're going to study over the course of the year, like forces or energy. And these are all quantities as opposed to a quality. A quality is something that you can't describe with a number, so something like maybe a color or a texture. Something feels smooth or bumpy. Like I said, anything that you can't really put a number to. You're going to find that a lot of things that you think are qualities actually could be quantities. Color, for instance, you can describe with a number. That's a little bit above the scope of physics in high school, but you can describe things with numbers, and we might get into that a little bit too. So, one of the first things that we also, you'll see in the definition there, is the word observable. If something is in the realm of physics, it's because it's something that we can observe or that we can test or something that we can see again and again. If it's not observable, then it doesn't fall under the realm of physics. So now there's tons of observable things, and so we tend to stick to lots of specific topics about motion or electricity or forces or energies, as opposed to maybe the life sciences, where you can talk about animals or the human body or lots of other things like that. That would be a biology or an anatomy class. But anyway, lots of things about the world are things that we study in physics. So a lot of physics is setting up different sorts of experiments, and whenever there's an experiment, there's usually some set of quantities that we're trying to find a relationship between. During an experiment, we usually describe two specific types of quantities. One is what we call an independent quantity, and another is a dependent quantity. The main difference between the two of those is that an independent quantity is something that the experimenter either chooses or directly controls, whereas the dependent quantity is something that they do not directly control. Inherent in its name is that it is the dependent quantity depends on something else, whereas independent does not. A lot of times when you graph something, an independent quantity, you'll choose to put that along the x-axis, and the dependent quantity you put along the y-axis. If you drew a quick little picture of this, this is how I like to remember it. The y-axis object depends on the x-axis. So anytime you see a graph, it's usually set up in this manner, that the y-axis, whatever quantity that is, it depends on the x-axis. In physics, one of the primary tools that we have to explore the world is the experiment. And anything that we can observe or try to come up with a relationship for, we usually have done from an experiment where we look at the data and we try to see how they're related. So I've got two different experiments here. The first is simply how far it might take for a vehicle, a car or a truck, to come to a stop. There are lots of quantities involved, and let's see which quantities are independent and which ones are dependent. Probably the most important quantity in all this is how far it takes for something to stop. And that, by and large, we can't directly control. That's going to depend on other things. So let's make a list. Here we will put all the independent quantities. And over here we'll put all the dependent quantities. And I think the primary dependent quantity is the braking distance. Now, what sort of things would affect braking distance? Probably the first thing that comes to my mind is how fast you're going. So we would say the initial velocity. That would be something that we could certainly control. We could go out and travel at 20 miles per hour or 50 miles per hour or 70 miles per hour and see how long it takes to stop each time. What other things could we say? The type of road surface. Now you might consider that a quality, but we'll learn when we get into forces that we can certainly quantify the types of surfaces involved. That's probably my favorite symbol of the whole thing is a Greek letter called mu, which has to do with the types of surfaces involved. You could say that maybe the temperature of the tires makes a difference. And we could heat up the tires or the road surface a little bit, or we could just go out on different days, once during the winter and once during the spring and once during the summer. So those would be some different things that might control things. Maybe the size of the car or the mass of the car. That's something that we could control. We could take out a SUV versus a tiny, I don't even know, small cars. I'm not very good with that. But those would be all different things that we could control, and each of those may or may not affect the braking distance. So how about a different experiment? Let's talk about the effect that a parachute might have on a falling object. So again, let's list some of the independent quantities that might be involved and some of the dependent quantities. I think probably the most important dependent quantity, something we can't directly control, would be how fast how fast we hit the ground. I can't specifically say I want to hit the ground at exactly 14.3 meters per second. It's not something I have control over. But that's certainly something we would want to understand because that depends on whether we or that determines whether or not we live or die, probably. So let's call that the impact velocity. So another thing that might be of interest to us would be how fast our maximum speed of falling would be. There's a term for that as well. That's called terminal velocity. Those things are certainly related a little bit as well. But neither of those things can I directly, specifically control. What I could control might be the height from which I fall, or the size of the parachute, say the area, the shape of a parachute, although shape is not something that is super quantifiable. It's more of a quality, but still, it's something that we would have some control over. And even the type of air that we're falling in, we may not be able to control it very easily in a high school classroom, but you can certainly remove the air and create a vacuum, or you can alter the air, make get a chamber that's very humid versus not very humid. So let's say the density of the air or the temperature of the air, those are all things that we could control. Temperature. And again, another thing that we can't necessarily control, but we have a little bit of control over is the gravity that we're involved in. We are kind of stuck here on Earth, but you could repeat this sort of experiment elsewhere. If we get the capability to move to the moon or to Mars where there are different gravitational fields, then that would be something that we could control. So here's a bunch of things of independent quantities and their related dependent quantities. And in many of our labs this year, you'll be making a graph, probably a scatter plot, and you would graph one of these quantities. These things would all be things that we would put on the x-axis, and any of these quantities would be things that we would put on the y-axis.